A SpaceX rocket launched early Friday with a U.S.-French satellite designed to conduct an unprecedented global survey of Earth's surface waters, a mission that is expected to shed new light on the mechanics and consequences of climate change. Welcome to Smarter Tech, and in this video, we'll take a look at SpaceX rocket sending first global water survey mission into orbit and latest updates you need to know. Elon Musk commercial rocket company's Falcon 9 booster lit up the pre-dawn sky along California's coast as it roared off its launch pad at the Vandenberg U.S. Space Force Base, about 160 miles northwest of Los Angeles. The upper stage of the Falcon 9, carrying the satellite, reached orbit in 9 minutes. The reusable lower stage had separated from the rocket and flown back to Earth, causing sonic booms before slowing to a gentle landing at the base. The mission's payload, the Surface Water and Ocean Topography Satellite, or SWOT, was launched less than an hour later and placed in its own starting orbit about 530 miles above the planet. SWOT was seen floating away in video from a camera mounted on the rocket's upper stage. NASA said that about a half-hour later, mission control of the French space agency, CNES, in Toulouse, France, reported that it had recovered the first complete set of signals from the satellite, confirming that SWOT systems were operational. The satellite's centerpiece is advanced microwave radar technology, which will connect high-definition measurements of oceans, lakes, reservoirs, and rivers across 90% of the globe. Researchers says the data, compiled from radar sweeps at least twice every 21 days, will be used to improve ocean circulation models, improve weather and climate forecasts, and aid in managing freshwater supplies in drought-stricken areas. NASA's Jet Propulsion Laboratory near Los Angeles and CNES built the majority of the SUV-sized satellite's components. SWOT was one of the 15 missions listed by the National Research Council as projects NASA should undertake in the coming decade, after nearly 20 years of development with contributions from counterparts in Canada and the United Kingdom. One major focus of the mission is to investigate how oceans absorb atmospheric heat and carbon dioxide, a process that naturally regulates global temperatures and contributes to climate change mitigation. According to scientists, the oceans have absorbed more than 90% of the excess heat trapped in the Earth's atmosphere as a result of human-caused greenhouse gas emissions. SWOT will be able to measure fine differences in surface elevations around smaller currents and eddies where much of the ocean's heat and carbon drawdown is thought to occur. Understanding that mechanism will aid in answering a critical question. What is the tipping point at which oceans begin releasing rather than absorbing large amounts of heat back into the atmosphere, thereby intensifying rather than limiting global warming? SWOT's ability to detect far smaller surface features over much larger areas than previous satellites will also aid in research into the effects of rising sea levels on coastal areas. SWOT is also capable of observing the entire length of nearly all rivers wider than 330 feet, as well as more than 1 million lakes and reservoirs larger than a few New York City blocks. Taking inventory of Earth's water resources on a regular basis during the SWOT mission's 3-year mission will allow researchers to better trace fluctuations in the planet's rivers and lakes during seasonal changes and major weather events. SWOT's radar instrument operates at the microwave spectrum's Ka-band frequency, allowing its scans to penetrate cloud cover and darkness and map observations in 2 dimensions. Previous water body studies relied on data collected at specific points or from satellites that could only track measurements along a one-dimensional line. Within months, the satellite is expected to begin collecting research data. SWOT was created by NASA and the French Space Agency with assistance from the Canadian and United Kingdom space agencies. It was recommended as a mission in the 2007 National Research Council Decadal Survey. Every 21 days, the satellite will study changes in global water levels and provide unprecedented detailed 3D volumetric data for Earth's oceans and millions of lakes and rivers across the majority of the planet. The nadir altimeter and the Ka-band radar interferometer, or CARIN for short, are SWOT's primary instruments. CARIN is made up of 2 antennas separated by a 33-foot-long boom that receive readings from Earth's surface independently. By the way, if you're watching us for the first time, make sure to hit that subscribe button and turn on notifications so you can enjoy our future videos while getting updated. Coming back to the topic, SWOT can measure water elevations with a 0.4-inch margin of error by using satellite position data and subsequent phase differences in signal reception. NASA Earth Science Division Director Karen St. Germain explained the upgrade that SWAT will bring to orbit in a pre-launch press conference. "We've been doing satellite altimetry measurements of sea surface height for 30 years, and that's a big part of the record we rely on to understand climate change," she explained. "What SWAT will do is improve the spatial resolution of our water height measurement by 10-fold. If we really want to understand the water cycle in meaningful ways, we need to be able to think about it in terms of volumes," SWAT hydrology science lead Tamlin Pavelski explained during a SWAT science briefing. "How much water is there, and how does it flow from one location to another? SWAT analysis will enable us to do so." According to Pavelski, prior to SWAT, the majority of satellite data available to scientists studying Earth's surface water was derived from readings from other experiments. "We are constantly having to figure out how to use data from satellites that weren't designed for what we want to do," he said. "We're repurposing other people's data and doing cool things with it." However, SWAT is the first satellite specifically designed to study rivers and lakes, and it will be a game changer. SWAT will be in charge of monitoring nearly 1.3 million miles of rivers and millions of lakes, as well as monitoring coastal sea levels to provide oceanic data in tandem with other on-orbit sources. NASA intends to make the mission's data public and is developing tools to make it easier to access in order to assist in sorting through the massive amount of data. "We can give really important information to a wide variety of stakeholders with the SWAT data," Benjamin Hamilton, research scientist for the Sea Level and Ice Group at NASA's Jet Propulsion Laboratory in Southern California, said during the briefing on Tuesday. "Anyone who cares about water should be concerned about what SWAT can offer. Some places have too much water while others don't," he explained. "Extreme droughts and floods are becoming common, and precipitation patterns are shifting. It is critical that we use the SWAT data to try to understand exactly what is going on." SWAT will spend 3 hours after separation from the Falcon 9 second stage performing instrument checks while its solar panels deploy and telemetry is transferred to satellite controllers in France. SWAT will begin a multi-part deployment of the Karen antenna in 4 days, which will take another 4 days to complete. Spacecraft controllers will orient SWAT toward the sun and begin powering up the remaining onboard components in 8 days. SWAT will undergo vehicle calibration for 6 months at its 532.5-mile altitude. Following that, the satellite will raise its orbit to 554 miles and begin its mission of surveying the planet's surface water every 21 days. The satellite's lifespan is said to be 3 years, but SWAT project manager Thierry Lafon believes it will be extended. "If everything is fine on board, our system will not limit the lifetime," he said before the launch. 5 years is completely reasonable and perhaps many more years, as we've been doing for 30 years, Lafon added, noting that many of NASA's satellites have far outlived their expected lifespans over 3 decades of Earth science research. SWAT was supposed to launch on Thursday morning, according to SpaceX and NASA. However, shortly before the planned liftoff, technicians discovered moisture in 2 of the Falcon 9's 9 first-stage Merlin engines, prompting the company to postpone the launch by a day to investigate the issue. And with that being said, it's time to end our video. Before that, we'd like to know what are your thoughts about the future of SpaceX. Let us know in the comments. Like this video and make sure to subscribe to our channel for more amazing videos like this. We'll see you in the next video.